Welcome, everybody. Thanks for joining us for this month's regularly scheduled webinar. For those of you who joined us yesterday for our special event, welcome back. We will talk about the color yellow and how you can achieve that with a variety of organic, inorganic, solvent dyes, and/or mica effect pigments. So as we've done in the past, we will be recording this webinar, and those of you who join us today will get the recording and the PDF of the presentation to share with your colleagues as well. So with that, I'm going to go off screen and we'll get started with the presentation. And if you have any questions along the way, feel free just to pop them in the chat box and I'll take care of them at the end of the presentation. So as I mentioned, we're going to talk about yellow with respect to organic, inorganic, solvent dyes, and mica effect pigments, all of which provide a different type of yellow color to your formulations. So when we talk about yellow, we want to, it's good to know that yellow is the color that the eye sees first. It's also very visible and very luminous as far as in comparison to other colors of the spectrum. It's a great tool in your communication toolbox because it is very direct, it's decisive, and because it's very visible, it tends to rise above all the other colors. But essentially, how you use it also dictates what communication you're trying to get across. So depending on what other colors you pair it with, a lot of what you see here on the screen, yellow and black really stand out. What shape are you applying it to? In this particular case, depending on the shape and what you're trying to achieve with your communication, you might want one shade of yellow or another. And also, what is the environment that it's going to be used in? What is your ultimate end customer? How are they going to see it? Is it going to be indoors, outdoors? So all of these types of questions would be taken into consideration when you're choosing the general color yellow and what shade and what effect that you're trying to achieve. So yellows fall into all colorant categories and classifications, both on the pigments and the dye sides, inorganic, organic. So in a lot of cases, these are all have a shade of yellow that you can use for your toolbox. So just to give you a feel for the yellow color space, typically when we talk about yellow, we talk about a green shade or a red shade. So this just gives you a feel for some of the color indexes that are typically used in the various application areas and where they fall in terms of that red shade, green shade space when we talk about it. So what I have here on this slide is a number of color indexes, both organic, inorganic, solvent dyes, and some mica effects, and where they fit in with respect to green shade to red shade. So on the greenest side, we've got some solvent yellows that are on the greener side. The pigment yellow 138 and pigment yellow 151 tend to be the most green shade of the yellows. In the center, we have some pigment yellow pigment yellow 62 and pigment yellow 191 fill that middle shade space that we talk about. And to the red side, we have our pigment yellow 110s and 139s and gold micas, as well as all the way to the red side is our CICP pigment brown 24. And just for those, the circled areas are the color indexes that Pseudoshan has for the yellow color space. So next is where what type of performance are you looking for with your color, especially with respect to organic pigments? Do you need a classical or the high performance area? So typically this is more of a fastness and heat resistance difference between the two, where the classical pigments tend to have low to middle fastness and low to middle heat resistance. Conversely, the high performance, as the name implies, provide those improved performances. So we'll first talk about the classical organic pigments. These fall into the azo aspect category, and typically these are very bright in color, typically relatively low in cost, and they have, as I mentioned earlier, poor to medium fastness and stability, heat stability. But they're used all over in printing inks, in paints, primarily architectural and artist colors. They are used in plastics and some specialty areas like seed coatings and crayons, chalks, that type of application. When we talk about azos, there are three subclasses of azo pigments, the mono azo, disazo, and laked azo. The mono azo, as the name implies, has one azo function, while the disazo has two azo functions. The laked azo is a mono azo, but it also has an extra site for salt formation. And so there are a number of yellow color indexes in each of these categories, subclasses. And in today's presentation, I'm not going to go through them all. So just an example of each one of these in terms of their chemistry. So for the mono azo, I've chosen the pigment yellow 74 as an example. So the mono, there's one azo functionality in this particular chemistry. The yellow 74 is more of a mid-shade yellow, so in between that red shade, green shade space that we reviewed earlier. It's a great light, fast, and economical, primarily for interior coatings and inks. Based on the particle sizing, they can be both transparent and opaque, and also depending on your requirement, the opaques can be more stabilized so that they have long-term stability in the crystal itself, which is our newest entry, is our Sudafast Yellow 130C. Moving over to the disazo, again, two azo functionalities in these structures. In this area, the example I chose was the pigment yellow 13. This is more to the redder side of the space. Typically, these are developed for both water and solvent inks and some plastic applications, but those are limited based on the heat stability. Pseudoshan products that fall into the yellow 13 category are yellow 169, which is as a transparent version for water-based inks, and the yellow 197D for solvent-based inks. And on the plastic sides, we do have the yellow 165. And then the laked azo, the example that I've included here is the pigment yellow 191. The salt that comes along with that is a calcium salt. Again, it's a mono azo, one mono azo functionality in the crystal structure, and the calcium salt. Yellow 191 is again is to the red side of the color space. This is a great pigment for plastic applications. It's due to its high heat stability and high opacity. And our workhorse product in this area is our Sudafast Yellow 129K. Moving on to the high performance azo pigments. In this case, there are two categories that fit this this classification: the benzimidazolone and the condensation disazo type of pigments. Again, they are used in all areas of application, but these are very good chemistries for both paints and plastics. Bring in more exterior types of applications. Again, exterior architectural, automotive, and industrial are very well suited for these types of chemistries. Benzimidazolone pigments are very useful, as we talked about yesterday in yesterday's webinar, for heavy metal pigment replacements. So, as the name implies, we wanted the chemist and very smart folks wanted to develop a new chemistry to improve upon the technical properties of the classical azos, primarily in bleed resistance and fastness to light and weathering. So two approaches that were done. The first approach was the disazo condensation approach, which enlarged the physical pigment molecule. And the second one was to lower the solubility of that particular pigment molecule, which is the benzimidazolone chemistry. For Pseudoshan, we only have the benzimidazolone type chemistries. We do not contain the disazo condensation in our portfolio. So some examples, again, these are developed for those improved light fastness, weather resistance, and higher heat resistance to get those higher performance applications in that yellow space. So Pigment Yellow 151 is, as I mentioned earlier, is to the green shade side. It is a very light, fast pigment and great durability for both coatings and inks, as well as plastics. So it does have an excellent migration properties for those plastic applications. Two products in our portfolio fill this space: the 2903 and the 2903K. Pigment Yellow 154 moves us into that mid-shade yellow color space. This is a great pigment because of its outstanding light and weather fastness, primarily used in coatings. However, we do see some usage in plastics and inks because of those fastest properties. I would say that the only negative property that we have with Pigment Yellow 154 is it, in comparison to other organic yellow pigments, it does have a lower tinting strength than other yellow pigments. Our product, of course, is the Pseudoperm Yellow 2906 in this color index space. Moving further, red is the Pigment Yellow 180. It is very heat stable pigment and is a great pigment for plastics if warping and shrinkage is an issue. It has great resistance to those types of properties. It also shows up in a number in coatings as well as inks, primarily because it does have great heat stability. Several products are in the line for us: the 2908, 2909, and then for inks, we have 2909D. The remaining high-performance yellow pigments come from the polycyclic category classification. And for the yellow space, it's the isoindolone and the pigment yellow 139 and the pigment yellow 138 are those spaces that Shan offers for high performance polycyclic pigments. This class of pigments is very unique because the actual chromophore are embedded tightly into that polycyclic structure. This class is a smaller class than the others. Primarily, they bring high value to your formulation because of their high technical properties as well as their high strength. So you get a lot of value in use when you bring in these high performance pigments into your color formulation. Pigment yellow 139 is to the red side. This is a good chemistry for light fastness and heat stability, primarily used in coatings, although we do see it in plastics as well. Again, particle size dependent on opacity. We offer two opaque grades, 2935, 2935P, and one transparent grade, the 2939K. Pigment yellow 110, the isoindolone, is also a red shade. It's going to be more red than the pigment yellow 139 we just spoke about. This is a fantastic pigment. It's pretty much the highest in terms of light fastness and heat stability, as well as weathering performance. These properties make it a great choice for both coatings and plastics, especially when exterior applications are required. Again, also particle size dependent for a transparent grade, the 29C, and several opaque grades as well. That transparency grade that provides a nice, rich formulation base when you're trying to achieve a gold formulation. So in this Aztec Gold Color of the Month that we prepared, we use the 2929C transparent yellow 110 as the base, primarily to offset and give a nice, deep, rich color and sparkle for the gold and gold micas that we placed into this formulation. And then lastly, the pigment yellow 138. This is our newest chemistry to Shan over the last couple of years. Pigment yellow 138 is to the green side, so it is one of the most green shade yellow pigments, organic pigments that is out there. It has great light, fast, and heat resistance, and primarily it's used in coatings and inks. Shan, when we built the plant, we wanted to make sure that we offered products to fill the entire color space. So because we are backward integrated all the way through, we're able to offer both a red shade and a green shade versions for the coatings and plastics applications areas. So one of the other things that we are extremely proud of is when we designed and went forward with our pigment yellow 138 plant, excuse me. It was designed in that entire plant would be operated and managed 100% by women. So we are extremely proud of the ladies of the Pigment Yellow 138 plant, and we love to celebrate them. And next month we will continue to celebrate them because it's International Women's Day next month on March 8th. So we will continue to celebrate this accomplishment for us. So moving over to the inorganic pigments, these would be our synthetic, our CICPs. In the yellow space, we have several in the rutile structure, crystal structure, as well as one in the spinel crystal structure. So the CICPs, they are synthetic crystalline with metal oxides. And because they're synthetic, all of the properties that they come with are tightly controlled versus mining the natural inorganic pigments. They are complex because there are at least 2 or more metals which provide the range of colors. They have great stability, color stability, and resistance to chemicals and solvents. Very high heat stability because of the way they're made. So that makes them a truly high performance pigments. Again, they're an inorganic, so they're going to have a much lower strength when you compare that to organic pigments. So the periodic table, as I mentioned, these are complex. So there's 2 or more metals that make up the color. So the orange or the red circles are responsible for the primary color, and in the yellow space, those elements are chromium, manganese, iron, and nickel. The other the triangle elements are there for balancing the charge and only modifying the particular hue. We start out with pigment yellow 53. It is the most yellow in the space, and its yellow is coming from nickel in that formulation. It is a rutile lattice structure. This is a very well-used pigment in the industry. It's also a great option for any of the chrome replacements that are needed to be done. Primarily giving an option to TiO2 when you're doing a replacement in here. TiO2 tends to blue up color quite a bit. So maybe replacing the TiO2 with the pigment yellow 53 allows for that yellowness to maintain in there. Today we have one product on the market, the 6406. In a couple of months, we will have our second product to fill that color space. Moving all the way over to the other side of the color space, to the red side, is the pigment brown 24. The color itself, the redness, comes from the chromium in that same rutile lattice structure. The pigment brown 24 is the largest volume CICP that is being used in the industries. It's a great opaque to visible light and fairly easy to disperse. Also, another useful tool in chrome replacements. Today we have our first product, the 6431, and looking forward to our second product in that space in the next couple of months. Pigment yellow 164, even though the color index says yellow, it's as you can tell, is more of a brown. And that brown color comes from the manganese in that same rutile lattice structure that we saw in the 2 other colors there. Again, we have our product 6411 that is our pigment yellow 164 in this space. Just to give you another visual of how changing that element in that same lattice structure changes the color. So we start with the pigment yellow 53, which contains the nickel. The pigment brown 24 is chromium, and then the yellow 164 is the manganese. And you can see the trend of color just by switching out the element in that lattice structure. In the spinel lattice structure, we have the pigment yellow 119. This is also a reddish buff shade in color. Our 6416 fits this space. And like the pigment brown 24, this is also would be a useful tool in replacing any kind of lead chromates. So we like to play around each month with putting out colors of the month. And in September of last year, we paid tribute to the beautiful sunflower. So our petals are the Pigment Yellow 139 and Pigment Yellow 180 in both full tone and tint tone plastic chips, while our seeds, if you will, are the Pigment Black 28 and Pigment Yellow 119. So that gives that nice brown color. Staying with the inorganic side is our other inorganic, which is our mica effect pigments. So the classification doesn't do it any justice by it's in the others category, but the luster is the mica effect pigments. A couple of ways to get there. The first one is the iridescence, where TiO2 is placed onto the mica flake. That gives that nice pearlescent look. However, it is going to be iridescent, so it's not going to provide much hiding aspect of it. But it does give that nice high chroma highlights to your formulations with that pearl luster that is very attractive. Also have two products in this space, the 4195, and if a surface treatment is required, we have a chrome-free version with our 41232 NXR. Moving to a more opaque version is where we get into the golds. Here we have a combination of TiO2 and iron oxide on the mica flake, which gives that very soft, warm gold color. And depending on what kind of color space you're looking for, we can alter those thicknesses to be able to move the color from green shade or to red shade, depending on the thicknesses. These do have better hiding because of that iron oxide that are on the surface there. So great chroma and improved durability and spray latitude. In this space, we have a number of products that are both in terms of color, from red shade to green shade, as well as size. So I mentioned as far as the color coming from the thickness in the TiO2 iridescent space, the yellow or gold is the second thinnest TiO2 after the silver. And then the golds are a combination of TiO2 on the surface of the mica, followed by a coating of iron oxide. And it's those two thicknesses that dictate what ultimate color that you will get. So the Semica 4195 is the iridescent. The Semica Bright Gold 4199 is a nice rich gold. These give nice creativity and in terms of your color communication. The golds, as you can imagine, represents wealth and prosperity. And formulating with these in terms of a color, it's always good to understand how the color will shift. And so what we did was we created a color wheel with the iridescent and the gold micas in each of the different primary and secondary color spaces. So if you follow me through the red space up top here, if we use the gold, the rich gold, the 4199, in combination with a pigment red 53, we get very rich and warm colors through the spaces. However, if you switch out to the iridescent gold on the left-hand side of this at the same formulations ratios, what you end up getting is a more deep color with sparkle. So depending on what you're looking for, it's always interesting to follow those through to see what kind of, again, what kind of communication are you trying to achieve, what the uh, what the part, what the shape is that you're going over. Do you want to see the edges a little bit more? So maybe you do an iridescent. Do you want to draw your customer in? Maybe you want the more richer color with the golds. And then, of course, what do you pair it with? So this gives you an idea of what to expect in those color formulation situations. Solvent dyes. These are in a class by themselves for a reason. Primarily used in plastics. These solvent dyes are used primarily because they are extremely highly transparent. So they offer up a lot of uh, physical properties that make it very attractive because of that transparency. Um, good for good fastness with respect to heat, but they are polymer specifics in here. So these are structured so that in previous talks we talked about the finishing of pigments, and where 75% of the performance come from the chemistry, the remaining 25% of the performance becomes from the finishing techniques that we put on. In this case, 100% of all of the properties are from that chemistry because these are not finished. So the color shade consistency is very good because it's all about the chemistry. So with pigments, you're always going to have a particle. No matter how big or small it is, a particle is always going to remain in that final part. And so what it's going to scatter the light, it's going to absorb and transmit it, and it also will reflect the light. So that's where your eye sees the color based off of those physical particles. In a dye, it's 100% absorption because there are no, if properly solubilized, there are no physical particles to scatter or reflect. Everything gets absorbed and transmitted through. So as far as in the yellow space, there are a couple of solvent yellows that we have. The solvent yellow 114 is a little bit more to the green shade in terms of its color. Very well suited for a variety of polymers. It has good heat stability as well. It's a pretty high volume solvent dye. We have our newest entry into the Sudasol brand name, our yellow 6746. To the red side is the solvent yellow 93. It's not as useful primarily because its chemistry does not allow for it to be FDA approved, so it does have a more limited, but it is a very good dye to be able to do that. We have one product here, the 6501. The transparency provides some very interesting uses to be able to accentuate a part. So in this case, we took advantage of the transparency of the solvent yellow 93 and combined it with the iridescent gold 4195. So on the face, we see a very clean transmitted color, so we can see right through it. But on the reflected side, we start to begin to see the sparkle of the mica, the richness of the mica that gives a very interesting color. So I talked about this earlier, where as far as pigments are concerned, we have these extra finishing and surface treatment steps that can alter the end product performance. But this is not the case with respect to solvent dyes. It's 100% based off of the chemistry. So those finishing steps can impact the application. So in general, as a pigment manufacturer, we develop pigments specifically for the ultimate end application. So we adjust what finishing steps we use for each of those applications, like plastics or coatings and inks. So but it's not to say that they can't be used in cross application areas. My job as the support person in technical is to make sure that all of our customers have the product that they need, not necessarily where it was developed for. Because dispersion is important. Primarily, this is more in the liquid areas of coatings and ink. However, dispersion in terms of plastics and powder coatings is also very important. With respect to liquid side, there's always wetting and grinding and stabilization needs to be taken into consideration. Ultimately, it doesn't matter what the application of the dispersion step is. Ultimately, we want to take the pigment out of the bag, which has a large number of very large agglomerates, and we want to get it fully separated as much as we can. And then once those are separated, we need to make sure that they're stabilized so they don't come back together again. From a dispersant perspective, it really is this goes on again on the liquid side, whether it's coatings or inks. It's a surface area dependency for our starting formulation. So an example would be the Pigment Yellow 110, where we have a transparent and an opaque. Surface area is very, very different, so it's going to require a different amount of active dispersant for that formulation to stabilize it. Excuse me. And then chemistry comes into play as well. So our Pigment Yellow 138, which is a semi-opaque, similar to the opaque, excuse me, Pigment Yellow 110. Its surface area is smaller, so it's going to require smaller amount of starting material for active dispersant. TEMs are always great to look at. This is a comparison of the Pigment Yellow 110, both opaque on the left and transparent on the right. The key area, again, as I mentioned, is the surface area. They both have the same shape. They're both in a needle-like crystal shape. However, it's the diameter of those crystals that makes the difference, resulting in a different surface area. So the transparent version has a higher surface area, smaller diameter, which is going to then require more dispersant. If we take a look at an ink formulation with Pigment Yellow 13, I'm sorry. In this example, I have the same Pigment Yellow 13, our Pseudocolor Yellow 169, but I'm comparing different chemistries of dispersants, all in the same amount, same D to P ratio, just these chemistries are very different. And what that results in is a different strength, anywhere from 98 to 104%, as well as opacity. We can get a more opaque or a less opaque in terms of the transparency or opacity, depending on which direction you're looking at, just by switching out the dispersant in here. So these finishing techniques need to be matched up with the dispersant as well. Moving on over onto the plastic performance, these pigments also need to be dispersed. The difference here is there's a much shorter residence time with respect to a dispersion in plastics. So it's key to make sure that we have the best performing pigment product up front as well. So the first block is a comparison for FPV, or sense of dispersibility. For the yellow 110, we took a look at both a couple of plastics versions as well as coatings. And you can see the value is very different depending on the chemistry. Switch over to the Pigment Yellow 180 and the 138, where we have some inks and coatings differences. Here, those surface treatments didn't affect the dispersibility. The bottom block is in warping, where the chemistry Pigment Yellow 110 is poor for warping, where the 180 is very good, as I mentioned earlier, and the 138 falls in between. And lastly, these are all high performance pigments, so their heat stability is very good, with the Pigment Yellow 138 at the very lower limit of a high performance category at 270-ish degrees Celsius. So all of our performance aspect here is on our portfolio here, where we have, and the yellow color shows up in each of the areas. Our high performance pigments are in the Pseudoperm brand. Our CICPs is our Pseudotherm brand. Inkjet has its own category for Pseudojet. Our solvent dyes are Pseudosol. And then we have our classical Azo pigments in the Pseudocolor range as well. And then our effects are Mica. So you can find yellows in each of these spaces, depending on where you need to be with your performance areas. Just a quick view of the yellow pigments for coatings, and these are all in our brochure as well as on the website. Pigments for plastics, pigments for inks and digital inks, our CICPs for both coatings and plastics applications, solvent dyes, and mica effect pigments. So these are all present and all available. You can find more information on our website. It's been updated. A couple of ways to do that is to go to our Pigments tab, and then you can view by application and sub-application. Or if you don't know where to start, you can put in the color index in the Pigment Finder selection box here, and it'll bring up all of the products in that color index category. So we are all here to support you and answer any questions that you might have. So feel free to reach out to any one of us, and we can get the information or samples that you need. Next up, next month, we will continue this theme. We're going to take a look at the orange and red space in this same type of idea. Interestingly enough, this will also be the March 28th at 11 o'clock, which is always the last Tuesday of the month. So take a look for that invitation and registration about a week ahead. And then in April, we will finish out our application areas with taking a look at pigments for coatings area. So I'd like to take this opportunity to thank you for giving us your time with this webinar. We're always happy to have you and continue to bringing you some technical information that you can use and include in your own library. So at this point, I'd like to open it up to any questions that you might have. And if you do have a question, feel free to bring them into the chat box and I can take it from there.